These little cutoff wheels are awesome. Moore's red cutoff wheels, 100 count aluminum oxide. They're 1.5 inches by 25 thou. You know, typical Dremel type cutoff wheel. So I'm going to switch that out and get a new wheel on there. So if you were going to use a handheld Dremel, you would stick it through there and use, again, this template as a guide. It works. It's a bit challenging. You'll break a few discs, but it gets the job done, and I've done dozens that way. So that will work. I'm going to show you a different way that might give you a little cleaner cut and save you some breakage. It wouldn't surprise me if we break one or two of these as we do it. Okay, I've got the drill press set on the highest RPM, and it's just not much. I'd prefer to use the mill for sure, but I just want to show you this. I'm not sure if we'll even finish it on this, but we'll give it a try. That's the process. It's slow as can be, but it works and you get a nice clean cut. The RPM on this drill press is pretty low. I'm going to take it over to the mill where I can get 3 times the RPM off of it, and it'll cut it a lot faster, but I did want to show you this method. If you don't have a mill, use one of these. If you don't have one of these, you can use that Dremel and use that as a guide and get that cut off. Okay, so we'll move over to the mill and finish this up. So we've got a nice clean cut, a little high on that side. It doesn't matter at all. So the whole point of that is just to stop cracking and give you a place to terminate your cut line there. So now what we need to do is, this is 70 thou. When you're opening a liner lock, 70 thou, and you get that lock bar bent over, 70 is just going to be too tight. So I always thin mine to around 55. Right there, and we'll put a little notch relief in there. Now I'm going to use the mill, but alternatively you can put an end mill into a drill press, just like we demonstrated showing cutting this, and mill this out, but you'll be able to transfer that. Or alternatively you can use a Dremel again with a small round Tootsie Roll sander and relieve some in this area and towards the back, so you can bend it with your thumb. And 55, 60 thou, anything more than that gets pretty tough to bend. So I'll set this up. We'll mill out just a little bit there with a 1/2 inch end mill to relieve that down to 55. I'll show you when we're done. So here we've just milled out this little relief, and this is 76 thou thick. So I relieved it 20 thou, and we'll go back and mic that, you know, plus or minus a few thou. It's not going to be a big deal. If you need to later on, you can always come back and take off more. So, you know, if you're not comfortable, leave it a little thicker. Come back, you can adjust that thinner later if the lock bar is too tight for you. And we've got to make a cut right there. I didn't, I cut this so I'd have a line to go to. Probably could have cut that, but then I probably got some chatter on this. So I'll use this same cutoff tool. Again, you could use a Dremel for that. You can use a bandsaw to make that cut. It's not that big a deal. And we'll adjust the lock face on the blade to fit this cut. A lot of guys will have you grind the lock face and then make the cut according to this. Here, I just find it's a little bit easier for me to make the cut here, and the design will allow the lock face to fit in there, and we'll grind up to that and get that to fit. So give me a minute, we'll get that cut. Okay, we've got the liners drilled, tapped, deburred, all of that. So I'm going to take this pivot barrel, get that onto one of the disc heads, get it into the liner side. So pretty real world issue. This pivot was a 1/2 thou oversize. Just got to lap it down. It's 360 grit, just chucked it up in the drill. So we've got the pivot in. We're going to put the blade in. This is the lock side. We'll get that there. Now on this design, there's a tab right there. That's going to go right over that stop pin. There's another tab right there, back here. And that's going to be for the stop pin at the top. Then at the bottom. Again, we're not going to drill through the liner, we're going to use the pattern because it's identical. So I'm going to get that, I'm going to close the blade to where I want it to rest. And pay attention to the tip. Now if you clip point it, you can bring the tip down. If you take out some of this belly here, that'll come up. So you can modify this design, and now would be the time to do that. We're just going to go ahead and finish this way. I'll probably clip some of that out, but that won't matter. Now I do want to leave room for a space bar. This one isn't for this style knife, but you'll get the idea. That's going to go in there like that. So we'll need to leave a little room for these screw holes and some of that getting in there. So I'm going to just set that about like that. That leaves me room up here for that space bar to come in with a little room there. In fact, I'll move it, clamp it, and I'm going to come through and I'll have to drill a pilot hole there because that's not a 1/8, so I'll drill that with a 49 and enlarge that. I don't have to go all the way through, I'm just marking it for a start point for my next drill operation. All right. So that stop pin is placed. I'm going to flip it over. I'm going to see where the profile is. I'm going to get it like that. Now, if you see there's some extra. We'll grind that flush later on when we match all the sides in the scales. But I'm going to get that about right there and clamp it. We're going to enlarge these holes with a 1/8 drill because that's the diameter of the stop pin and we want that to rest in there. Now we've got the stop pin locations, and we're going to grind this back. So we're going to take out about half of the diameter there. And this little part really doesn't serve any function because the pin is going to rest right there. On this one, the pin's going to rest right there, so all of this is extra, and we'll take all of that off. So I've taken out half of the diameter there. This little thing gets sharp and gets caught on your finger sometimes when you're opening and close, so we'll grind that a little smoother. Again, your stop pin is going to be resting right in that area, and that's where all the pressure is, and there's more than enough metal that will be left over to hold that securely. In this particular case, your stop pin is going to be resting right there, so we're going to take just about all of that. This little corner right there, as the blade rotates, interferes. So I'm going to take and just lop that off. Again, your blade's going to be resting right in there. Don't touch your belt where the pivot's going to rest. That's all there was to it. If it needs trim, we'll come back and clean it up again. So this is how it looks. I just put a temporary stop pin in there, and when there's only one liner, it wobbles around. When there gets to be two liners, that'll firm up, but for now, this is going to be close enough, and it just shows kind of how that works, and that's set. That's set, done deal. It's the slickest way that I've seen to do a stop pin. You can take a Dremel with a 1/8 carbide. If you want it to close into the blade a little bit more, you mill where that's going to touch, and you'll bring that up. If your blade is canted down a little bit too much, again, you would mill in right there, but we've set it exactly where we want it. I won't touch it again. That's going to be where it's going to be. This is a silicone cup, and it was in a big sheet. Cut them all out. I always keep all my spare parts in there as I'm working on a knife, and I've got everything that I need right in one place. So what we'll do now is we'll put a detent ball in here. That's a little 2mm, and we'll press fit that. Now this is a number 49 hole, and that's just a couple thou smaller than these ceramic ball bearings. This is typical half-ton arbor press. They're everywhere. Harbor Freight has them pretty cheap. We have drilled a hole up here, and we do sell these. You can make your own, but you're gonna have to drill a hole up in your ram. That's pretty sure it's a 3/8. If you look, you can see a bunch of dimples in there where I've set a bunch. This is just mild steel. It's not hardened. It's not been a problem. It works. Probably could just put a hardened pin in there if I wanted, but this works too. It's impossible to grab by your fingers, so just going to set that on top of there. Now I've got this 15 thou washer, and I'm going to use that as a spacer, and we want that detent ball to sit proud of there, and the washer will prevent the ram from going down all the way. And I just felt it sink in. So that's it. Now what we'll do is we'll measure how far we've got that in there, and I want that about 20 to 25 thou above the surface. I use a digital micrometer. It's accurate to 1/2 of a thou. This is an anvil that holds it. Really handy to give yourself something. I'll use this dozens of times. But what I'm going to do is I'm going to measure the thickness of the tie, and that should be around 75/6. Now these come with a little clicker on the end, some of them, and what that's for is if you crank it down using the big knurled part, you can really change the dimension by just squeezing it down. You use this little clicker and you get consistent pressure every time. I'm measuring 74 thou on that piece. Now I'm going to go over and measure how far that ball is sticking out. And I'm at 109, so that gives me about 35 thou over. A little bit more than I want, so I'm going to try and squeeze that down just a bit more. And it's only going to go so far because of the hole. Now the ceramic you can't pound in. You'll shatter them. Tried that, didn't work. Use a press. Now you can also use a vise with a flat piece of metal there. Back it up, squeeze it in, super glue the ball in place, and then squeeze it in. The super glue won't matter. At 103, so that puts me about 30 over. I'm going to leave that and see. I'm going to be okay with that. It's a lot, but it really gives us a good, strong closed position lockup. What we want to do here now is bend the lock bar. Made this, it's called a crick. I don't know who made that name up. To bend like this, put that over that little relief and bend that, but I always find that I bend the tie when I do that. I'm kind of strong arming this and bending that. So what I'm going to do is I'm going to take this over to a vise, give it a little heat, and then bend it, and I won't bend up so much. I'll keep my metal flat. Now, before I started, and I probably should have showed this, is I checked to see how flat this material was, and it was dead flat. If it wasn't, you'll have to take some time to straighten it. Straightening metal is part of knife making. You're just not going to get perfect parts every time. It sure be great world if you did, but that's not real. And if you saw how steel and titanium is rolled, you'd understand why it's rarely perfectly flat. So I checked this on a surface plate, which I have right here, or I could use some parallels or whatever flat surface. These 1, 2, 3 blocks are pretty flat, but then you're not quite the full length of it. Quick touch with the torch, just cherry red, and we'll bend that lock bar in. I'm putting all the heat right on that relief because that's where I want the bend to take. And you should just be able to feel that tie just move over. It'll just soften up and it'll just move. It doesn't take much pressure. I'm going to bring that out 1/4 of an inch, dunk it in water and cool it off. So now we've got this detent riding in there and there, and I already messed up. I should have drilled the detent hole, so we'll have to push that detent ball out. Okay, so there's my little detent. I'm not going to reuse it. They're pennies. Stop pin's in there pretty firm. I pounded it through so it doesn't wobble around so much. Still just a touch, but we're okay. So there's that. That's all set exactly where we want it. Now this is the one time we will drill through the liner. This is a number 49 hole, and that fits the 2mm detent. Now if you're going to use a 1/16 ball, you can, nothing changes. Except when you drill this first hole, you're going to have to drill that just undersize, a few thou under for your 16th. I want a smaller hole in this blade, and I can always come back and enlarge it if it isn't quite tight. Otherwise, the surface of that ball bearing that's press fit into the lock bar should engage that hole, and we're not looking to get it to fall in all the way. We just want it in 1/3 of the way. So I'll touch this with a 49 because that's the size hole that we're dealing with, just to mark it, and then I'm going to follow it up with a 52. That was it, just enough to mark it for the 52. This is a hand chuck as opposed to a key chuck where you do that. You're going to get a lot more precision out of them. They're 30 to 200 bucks. I think this one might have cost 30, 40 bucks. Knock off the other chuck, push that back in. There's just a friction fit holding these things. Sometimes there's a drift socket in the ram here, and it's on, not on this one. The smaller ones don't have it, so you just got to get that other chuck off, put this on. Really worth the money. So now I've got my detent hole just started, just to mark, and I'm going to drill that halfway into the blade, and if I got to enlarge it later, I'll do that. You can go all the way through. See lots of blades where this hole goes all the way through. There's an argument about to be made for that too. Stops dust from building up in there and interfering with your close position. Never really had that issue. Now the detent closed hole is set, we'll put that detent back in. All right, we're sitting in at 100 thou, again 76, so we're 24 thou proud of the surface. Perfect. Not a problem, and it's in there to stay. It's not coming out. I'll just put a little pressure there. I can feel where that snaps at right in place. It's perfectly aligned, so there's no guessing where to drill that, no guessing where to drill those, and that's kind of the beauty of this template setup this way. And I feel pretty good about how that engages, just loose enough. Now if I wanted to engage more, I'll enlarge that hole. If it's just a little bit too much, I'll chamfer the hole and give the ball bearing an easier path to exit. But for now I'm going to leave it like that, and I know that kind of works. What we're going to do now is we're going to go over and grind the lock face, and we'll have to put a line in here. I'm going to just put an angle there, so I know that's the side I got to take off. Because after you grind one backwards, one or twice, and you lose all that work, you're going to pay attention. Open it up, hold it open best I can, and then I'm going to take a razor blade on this back side, and I'm going to just scrape a little mark in there so I have a reference line. Probably don't need it, but I guess it's a habit, and I do it. I know I don't want to, when I start sneaking up on this line to engage this lock face, that lock bar against that lock face, I got to pay attention. Now one other thing, so we're going to put about an 8.5 degree on there, and I'm going to put about a 1 or 2 degree right on this, because it's dead, I mean it's perpendicular, it's a sharp edge, and I'm going to just touch this corner right here with a grinder with a 120 grit, and I'm just going to try and do my best to put a 1 degree, 2 degree bevel on this lock face. That'll have about an 8, 8.5 on the blade, so it's going to end up somewhere around a 9. That's, if we come out right, about a 9 degree intersection on that. So and I'm just using the screwdriver to hold it open a bit, just a small touch. Got my pivot, got my blade, now let's go over and grind the lock face. This is a little ramp I made out of just some scrap aluminum. I scribed a line, ground that down to an 8.5 degree ramp. As long as you set up your grinder the same way, this is 90 degrees. Now I happen to know this is about 89 degrees because I've measured this. And that all works out in the geometry for me, but check to see that this is 90 degrees to your table. You're going to use a ramp like that. Now, I paid attention and put my mark there, so I know I'm going to put that right up there, and I'm going to grind it. Now, when you set your lock face, you want the contact point as far down here as you can get it, and nothing touching up there. Okay, so we may have to grind this back just a little bit to give us a point there. Now, it's exaggerated, but just enough to give clearance for that lock bar to not interfere up in this area, but you just want your point of contact right down there. And now I've got a 120 degree belt in here. I'm going to turn the speed way down. I'm going to grind it, I'm going to check it, I'm going to grind it, I'm going to check it, and I'm just going to walk in until this lock bar just barely engages that. Later on, I'm going to come back and probably tune this up, and I'll probably hit this again to get the engagement that I want this lock bar to engage the lock face. I prefer around a 50% engagement. Some guys want it really early. I don't do it that way, and you don't want this bar all the way over there because then you're going to get lock rock when it's open. I've got my little scribe line in there. You probably can't see it, but I'm looking at that and checking that reference. I know I've got quite a bit of ways to go, but you know what? It takes, the more time you spend on this, honestly, the better off you're gonna be, because you can't take and put metal back on. So we're just gonna sneak up on this. You look right towards the bottom where the ball is. I've ground this back at an angle, pretty exaggerated, probably more like that, to get away from any interference up top here, and I've cleared that pretty good there, okay? So this part is clear. I'm not gonna get any binding up there, so now I'm just down to this little bit, and I have 4 or 5 thou more to go, and then that will engage. Take your time. If you go too short on this, you either make a new blade or a new liner. Just wanting to start to break through. There it is. Now that's about a 50% engagement right there, but when we tighten it up, we get the stop pin in there tight, we'll actually move the engagement a little earlier on that, but for now, we're good. See this pivot, even as tight as this pivot is in that pivot hole, and as tight as this stop pin is there, it's still gonna give. When we get the other liner on there and snug everything up, this whole thing firms up, and you'll find the engagement tends to move a little bit earlier, and that's kind of where we're targeting for. I want to get about 1/3 engagement on this thickness blade and this thickness tie. That'll give the blade plenty of life and lots of wear life in there, and that should hold up for quite a while. Most guys will say 8.5 to 9.5 to 10 degrees. If you get too flat, and so you're down 6-7 degrees, and you get that, the blade tends to lock up, and it just engages and it sticks. If you get 11, 12, 13 degrees, and again, this is different for each maker, and for some guys it might work for 12. In your shop, work it out, figure out what's going to work best. Shoot for around 9 degrees, 9.5, and you're going to be kind of right in the middle of the park. If you get above 12, 13 degrees, and your ramp, you know, say it's like that, and you take your ramp like that, the lock's going to be slippery. When you check your lock up, it's going to just pop right off. So one of the things that you're going to want to look at, now this blade thickness is 133 thou, so it's a fat 1/8. I will take and get this flat. All we're concerned about getting flat is this area right here where the washers and where that mechanism is, and you get that flat in there, and the rest can be off a little bit. Now when I say flat, you're going to be within 1 thou or 2 thickness, and sometimes 3 thou. So when you see this next, I'll have taken this over to the disc grinder and taken out all these heavy god-awful marks here that's left over from cleaning up scale and what have you. I would expect I'll lose half a dozen, maybe 10 thou in thickness. These scratches are pretty deep, don't want those in there. So I may end up 120, that'd be 13 thou. Doesn't matter on the design, we'll adjust everything for that. You're gonna get this to the thickness that you want, and then you're gonna adjust your parts and your space bar to fit the thickness, taking into account the washers.